Good morning, everyone. So this session is on performance testing Java applications. And what we're going to do is we're not going to talk about low-level performance, even though I can do that. And the company that I work for, Azul Systems, we specialize in low-level performance on the JVM. What I've found over the years with working with customers is that the entire process of doing performance testing is a little bit of a mystery to most people. So that's what I want to do in this session today, is to outline the 9 large steps that you have to do as a Java developer or a performance engineer or whatever to understand how to actually test a Java application and set goals and things like that. So this is a little bit higher level talk, but we'll do some demos along the way. And if you have any questions at any point in time, please feel free to ask them, okay? So my name is Pratik Patel. I work at Azul Systems, and I'm based out of Atlanta. I help run the Atlanta Java User Group, which is one of the largest JUGs in the US. And we run a little conference there called DevNexus out of that user group. You may have heard of that, okay? And just a few words about Azul before we get into this presentation. We have some free builds of OpenJDK that we provide that lots and lots of people use. I think on a monthly basis, there's like something like 10 or 15 million downloads of the free Azul OpenJDKs. And then we also have a high-performance JDK called Azul Platform Prime, which lots and lots of different people use, like Netflix, for example, uses it. Most investment banks, et cetera, use it as well. Okay. One other quick thing, we also have a nice community website called Fujay where you can go and write articles, and it's completely free. There's lots and lots of great articles and content. I actually just took the screenshot this morning, so you can see some of the new stuff that's been published by community authors on here. But this is a project that we sponsor, and it's called Fujay, or Friends of OpenJDK. I'm not sure who came up with that name, but anyways, we'll talk a little bit more about Azul JVMs in a minute, but again, we have a high-performance Java virtual machine. It's a drop-in replacement for OpenJDK. You don't have to change any code. If you wish to talk about that, our booth is right outside, and we have these fancy JVM hats, so you can come and pick one of those up too, if you like, okay? All right, so let's get into this specific presentation. Why listen to this session? Why specifically listen to me give this session? Right, I like to start with that. Has anybody, I know we're in Sweden, but has anybody ever heard of AT&T? It's a large telco in the US. People have heard of it? Okay. So I used to work at AT&T, and I led the Java performance team there for 5 years. And we were running approximately 600 Java EE servers in production, right? And it was a full stack with, Oracle database in the back and stuff like that. So we did full stack testing, but the main part of the testing that we focused on was around making sure that the Java EE servers did not fall down in production under heavy load. So I'm going to talk quite a bit about that in this session, some of the lessons learned from that, to hopefully give you an idea of what that looks like. Okay. Does anybody know what this show is? Okay. So after I left AT&T, I went to a startup, and this show was on at the same time, and I had to stop watching it because it was too much like real life. If you watch the show, you know what I mean. Like, if you remember, there's that episode where they had a consultant that they paid $20,000 a day, and that consultant didn't do much. That was us. So, well, we hired somebody. Anyways, there's going to be a lot of questions in this. So if you don't mind, this is, I think, the 5th or 6th time I've spoken at JFocus, and usually the audience is very engaged. So I have a lot of questions here that I'm going to ask you. So the first question is, what's the best way to fix Java performance issues? Anyone want to take a guess? Oh, come on, there's got to be at least one adventurous or courageous person that's willing to answer it. Yes? Using C++. That's not a bad answer, but then the problem is you're using C++ and your life is miserable. So, oh wait, this isn't being recorded, is it? Okay, just kidding. Anybody else? Come on, there's got to be at least somebody else. Write in Rust. Okay, that's interesting. But then you're writing in Rust, and again, your life is miserable. So, anyone else? Think about Java, right? How can you? What's that? Tweaking. Okay, that's a good answer. And you can spend your entire life tweaking a Java application, and that's something we're not going to talk about in this session because in today's modern Java, especially with like the latest JDK 17, you actually don't need to do a lot of tweaking. And if you do need to tweak your code or JVM settings, the answer to what you need to do is actually fairly obvious, right? You don't have to spend a lot of time doing it nowadays, okay? So this is a trick question, by the way. The answer is it depends, of course, right? So, but there will be other questions, hopefully, that you guys will be able to tune in. But in my opinion, the hardest thing for fixing performance issues in Java, or any system for that matter, whether it's JavaScript, Rust, or someone said C++, is actually just finding the problem, right? In my opinion and in my experience, that's usually 90% of the work, is just figuring out what is wrong, right? So that's what this session focuses around, is how do you figure out what's wrong, and how do you set goals, and how do you structure a test environment to be able to do something like this. So, of course, this is a lot easier said than done, right? Because usually, if you have a performance problem in your code, or there's something wrong with the environment, it's usually pretty easy to figure out what that problem is and fix it, right? It's the hard problems that take up all of your time. You probably heard of the 80-20 rule, right? You spend 80% of your time digging to try to find something, and then maybe 20% of your time actually trying to fix it, right? So let's get started with some steps for successful performance testing. All right, so step number 1, set up a performance test. Step number 2, run the perf test, ... and profit, of course, right? So the part that we're going to be talking about is that ... Right, so again, this is a high-level framework. We'll do a few demos in a few minutes to show you some of the tools that I use to look at Java performance issues, or find Java performance issues, understanding Java systems better, et cetera. But at the very, very high level, as a software developer, I generally want to skip these 3 steps, right? Defining your goals, very important, because you can performance tune something forever. But at some point, you have to say to yourself, what is it that we actually want to attain out of this system, right? What kind of throughput do we want? What is the amount of latency we're willing to tolerate? Other things like that. Okay, the second thing, again, this is before you start running performance tests, is thinking about your environment. Where are you running? Are you running on bare metal? Are you running in a Kubernetes environment? How many people run Kubernetes, out of curiosity? Well, that's quite a bit. I wouldn't think that it would be that popular, but okay. And then, of course, probably the biggest point on this slide is thinking about your application and understanding your app well enough to be able to put together a performance test plan for it, okay? All right, so 3 steps during testing. Operating system settings. We'll get into each one of these in a little bit more detail in a few minutes. And then we'll look at some tools for performance testing. How do you collect performance test data, and what do you do with it? Okay, and then 3 steps after testing: analyzing performance results, finding bottlenecks, and then, of course, fixing the performance problem, and then repeating the testing to make sure whatever fix you made actually works, right? All right, so let's talk about the first one. I'm going to spend a little bit of time on this section because there's some specific nomenclature, the way that performance engineers talk. I think it's useful to understand that, right? So when I'm looking at a system, when I'm working with a customer, for example, I think in terms of throughput and latency, right? Because throughput and latency are mutually exclusive. That means that the more throughput you put through the system, the higher the latency is going to be, generally speaking, right? Or vice versa. If you want low latency, you can have low latency, but your throughput will not be that great or won't be that high, right? So the amount of load you put through a system will affect latency, whether it's a Java system or any other system that you're testing, okay? And then the other things in terms of performance test goals and defining a plan is, what is the actual SLA and what kind of stability are you looking for? Right? An SLA could be something like, we want this system to be able to respond to a request within 300 milliseconds, right? It's very simple. You know what SLAs are. Everyone in this room has probably dealt with SLAs in the past, right? And then, of course, there's the stability. The stability is how much load can we put on a system before it affects the latency, which affects the overall stability of that specific application or that cluster of apps or whatever, okay? So these are the 4 different axes that I generally tend to think about when I'm thinking about performance, okay? But let's jump into this a little bit deeper here. So one of the things that, how many people are familiar with the phrase P99? Okay, so roughly about 10% of the audience, good. So when we talk about performance testing, we think in terms of this thing called P99, or the 99th percentile, or the 95th percentile. Let's see what that looks like, Okay? Let's put it into words first. So when we think of P99, we say 99% of the requests should be faster than the given latency. What's the given latency? Well, that's up to you or your business people or whatever. I made a quick example earlier where I said 300 milliseconds is acceptable latency for this system. It could be much higher, right? If you use a lot of large websites, for example, like in the US, we have Amazon. You have Amazon here in Sweden too. Okay, good. Whatever it is, right? If you go to Amazon and you click around, you'll notice that things aren't instantaneous. They can be, but what they do is they say, we believe that a user will tolerate 1 to 2 seconds of latency when they click on something to add something to their shopping cart or checkout or whatever, okay? And the reason why you do that is because, or why they do that, is because the lower you want your latency to be, the more processing power you have to throw at it. Of course, processing power comes down to money at the end of the day, right? So again, it's the spectrum. How much is the user willing to tolerate? How much are we willing to tolerate to put the user through? Okay. So anyways, getting back to P99. So the flip side of 99% requests should be faster than the given latency is that we expect only 1% of the requests to be slower than that latency. Okay, so this is a kind of goal that we set when we are looking at trying to figure out how to improve the performance in a system so that we have a goal, right? Because a goal that is, let's make the system run faster, that's not a goal, right? That's just something like you dream up and say, oh, you know, I have infinite amount of time, and I love working on this on Saturday night, so I'm just going to keep working and try to make it faster. You have to have a goal, okay? Now, let's look at this in a chart form. I think this will help illustrate the point a little bit better, okay? So, on the left side of this chart, we have the number of requests and the latency under which those requests fall. Okay, so you can, if you look at the math, I've tried to make the math as easy as possible here. There's 100 total requests here, right, so that we can do the math in our head easy. And this is the amount of latency. So for example, 10 requests had less than 2-second latency. Okay, so if we look at this chart, right, we will produce this chart in a few minutes, well, in a graph form, but we can also get this data using a number of different tools. But if we look at this chart, this table, we can say that the P95 or 95% of requests finish in less than 7 seconds. Okay, so that's our P95. Our P99 is 7 seconds, i.e. 1% of requests take longer than 7 seconds. Okay, so as a performance engineer, this is how we quantify how our system performs. Where's the line for the outlier for the 99% of requests that are coming into the system, right? And what are the ones which are faster than that? Okay, so you can see from this chart how this works. So this is how we think about it, okay? But we also think about the latency in a few other ways, right? Of course, we think about what's the kind of minimum time or average minimum time that we see, what's the median time for a request to complete, and what's the big outliers, right? So in this example, you can see that I say that the maximum latency that we saw during a performance test run or on production was 7.2 seconds, and you know, using the chart that was in the previous slide, we can say, oh, maybe the P95 is 0.5 seconds, but the P99 is 1.3 seconds. So again, for 95% of users, the latency was below 0.5 seconds. And then you go to your business people and you ask them, is this good enough? Do we need to do more to make this better? Right? And at some point, you will have that discussion with them because they want it to be as fast as possible. But then you say, well, we can have like 100 millisecond latency, but then we'll have to spend 3 times more on infrastructure. Right? And is that worth it for our company? All right. So some other ways to think about this, right, especially when you're talking to a customer or your business people at your company, we want 99% of users to have less than 2-second latency. That's a concrete goal, okay? If you're using infrastructure like Kafka, you can say we need to push 100,000 messages through 100,000 messages a second through a Kafka instance or a Kafka cluster. Again, these are ways that we quantify what our performance should look like. Okay? Other ways, right, when we're talking, sometimes maybe not the business people, but other engineers, we want a P95 of less than 500 milliseconds, or we want a P99 of less than 5 seconds so that the outliers are minimized. Okay? So, we're going to look at this in graph form in just a second. We're going to actually produce this graph using this tool called the histogram log analyzer, another tool which I'm going to introduce. Okay. All right, so let's talk about the environment for just a second. Surprisingly, this makes a big impact on how fast you're running, right? So we don't have time to get into all these bullets, unfortunately, because this is only an hour session. But are you running on-prem? Are you running in the cloud? Is it a single server? Are you running in a distributed fashion, a distributed monolith? Or are you running Kubernetes, right? All those types of things. All right, but I think the important bullet on this slide is the second one. Where are you doing your performance testing? Okay, so here's a question. Where's the best place to do performance testing? Production. I'm going to print a t-shirt one day that says, I don't normally test, but when I do test, I test on production, right? But production is the best place to do this. Now, how many people, if you went to your team or to your manager or whoever and said, hey, we want to run some performance tests on production, how many people would say, yeah, let's do that? Right. That's a little bit of a problem, right? So I'll tell you a quick story from my time at AT&T. I had this exact same problem, because we were having all sorts of performance issues because of database locking that bled into the application layer and stuff like that. And I said, well, the best place to test on production is, because we're running 600 Java EE servers, is the best place to do performance testing is on production. And they're like, no way. I said, okay, that's fine. So what I did is I wrote up a plan for how much it would cost to replicate production. And it worked out to be about $3 million, right, at the time. And I took that to them, to my management, and I said, okay, you won't let me do performance testing on production, so here's how much it will cost. And guess what they did? What's that? No, actually, they gave me $3 million to build out that environment. So the moral of the story is, you never know until you ask, right? Because for your manager or for your business people, it's all about risk and profit and stuff like that. So for a company like AT&T, which, this system had hundreds of developers working on it, it was totally worth it for them to not risk a production outage because I was doing performance testing and they just gave me money to build out this gigantic environment, okay? So it doesn't hurt to ask is what I'm getting at. But getting back to this, the best place to test is on production. And I'm actually going to show you a couple of tools that I use when I work with customers at Azul to test on production. You can do it in what we call a non-intrusive way. You can collect data and get most of the way there, find problems without really affecting a running performance system, right? And of course, the second best thing is to have a full production performance test environment, and then less than that would be staging and then having like a test environment that's just for other things too, right? You test where you can, depending on what you can get. Okay, so production performance analysis is always the best. It can be non-intrusive. We're going to look at a couple of tools that help you do that. Now, what's the problem with replicating a production environment? What do you think? What would be the hardest thing? If say you're running like 100 servers in production, right? Java servers, yes. Generating the same load. Actually, it's quite easy to generate load, believe it or not. Right? So that's not a bad answer. It's tricky generating exactly what your load looks like on production in a production mirror environment, but that's not quite it. Yes, data. Well, what if you have 5 petabytes of data? Are you going to replicate that? Probably not, right? That would cost a lot of money to do that. I don't know how much storage on AWS Aurora or GCP Alloy DB is, but it's not cheap, right? So it's the data that becomes a problem here. So you have to be creative with trying to replicate that data or just have a slice of data and then trying to run a performance test. But again, in that case, the best place to test is production. We can do it in a non-intrusive way, okay? So those non-intrusive tools that I was referring to is actually the 3 things here. Just looking at garbage collection logs and taking thread dumps. And then I'm going to show you a tool called JHiccup in a few minutes. But one thing that I've had success doing is when I'm working with a customer, I'll say, you know what, you're running like 20 of these instances of this large Java application in production. Why don't we just go and set up some of these tools on one of those 20? Because then if it won't bring the whole system down in case something goes wrong, right? It'll just bring down 1/20th of the nodes that they have in production. So sometimes that's a good compromise in terms of being able to test on production when you don't have a full production mirror to test on. All right, so I don't have time to talk about cloud deployments because this is probably a 3-hour presentation, just talking about the cloud and performance specifically for the cloud and things like that. But one of the things that's nice today is, I made the joke earlier how I asked for $3 million to build out a performance environment. But that was kind of in the very early days of the cloud. But nowadays, you can actually use something like Terraform. Is everyone familiar with Terraform? Okay, most people know what Terraform is. It's basically a language, for lack of a better way of saying it, or tool that allows you to quickly build up infrastructure in the cloud, do what you need to do, and then bring it down, right? So you can build a Terraform script. Everyone has a Terraform script that looks exactly like their production cloud environment, right? Okay, I'll take that as a no. But hopefully you do. If you don't, you can obviously build one. But nice thing about using on-demand services, whether it's on AWS, Azure, or GCP, is that you can write a Terraform script that looks like your production environment, spin it up, run your performance test, and then spin all of it down, so you're not paying a lot of money to keep that thing running all the time. Okay? But when we're testing on the cloud, there's a lot of different things that we think about. The cloud-based deployments generally tend to be horizontally scaled instead of vertically scaled. So that's something that we have to think about. And what's the networking look like behind it? Are you using storage? How fast is that storage? Et cetera, right? So these are all things that we have to think about. And cloud environments generally tend to be more constrained than dedicated on-prem environments that you have. CPU slices on the cloud generally tend to be very, very small. So that can be a little bit of a problem. Storage might be slower. There's networking overhead, et cetera, et cetera. Okay. Again, this is an entire 2 or 3 hour presentation. So we'll move on and think about our application. And there's not really much to say here because I don't know your application. You know your application pretty well. Are you using Spring Boot? Are you still running Java EE? Are you using external streaming? Do you have a external from your application bottleneck like a database? All those things come into play, and you have to understand like what's going on there, right? But I'll tell you a quick story. I was working with a customer recently, and it was taking their Spring Boot application about 25 to 27 minutes to come online, right, to get booted up. It was an old app. It was using Apache OJB. Does anybody remember what that is? Apache OJB. We're going 15 years into the past. No one's heard of that before? It's basically an object mapping system that predates Hibernate and everything. Oh, they were using something called struts also. You may have heard of that one. So anyways, it was taking and we were trying to run performance tests, and every time we make a change, we'd have to wait 25 minutes for it to boot up or to come online. And I was like, wow, why is this taking so long? So guess what I did to take that boot up time from 25 minutes to 7 minutes? It's really simple. Remember, it was using old technology. That doesn't really have anything to do with it, but a little bit. So what I did is I went in and I set the Spring configuration logging. You know how like when Spring starts up, it does all this stuff, and it says, I'm doing this, and I'm setting this bean, and blah, blah, blah. I just turned that to error instead of it was on info, and that reduced the boot up time from 25 minutes to 7 minutes, right? So it's simple things like that, believe it or not, that can make a huge difference. All right, so reactive is not a silver bullet for performance. How many people are doing Vertex or other kind of reactive programming for production? Okay, a few people. All right, interesting. So reactive is not a silver bullet for performance, and usually, unfortunately, but you get the idea. And of course, you know your application. Do you have uneven load? Nobody has load that looks like this during the course of the day. What does your load on your system look like? It looks like this, right? It goes up and down. So capturing when that peak is the most important part of this, is what is my peak, right? That's one of the first things that you need to know is what is that peak during, I don't know, whatever your system is doing with time of day. So if it's like, you know, if 8 a.m. is the busiest time for your system, what is that peak at that point in time? That's what you should be shooting for in terms of how much load do we need to replicate, right? And then, of course, if you're using Kubernetes, do we auto-scale, and does it do redistribution of load and other things like that? So, all right, let's move on to the next topic so that we can get to our demos. Let's talk about operating system settings. So these are a couple of flags that I have up here that most of you probably should be running on. You know, you set ulimit should be unlimited always, and then you set the minimum free kilobytes in the VM. But here's the thing that most people don't recognize right off the top. If you're running a Java application, usually, everyone runs on Linux or some flavor of Linux, probably, right? Anyone run their Java app on Windows out of curiosity? Okay, a few people. So it doesn't matter what operating system you use, let's just use Linux as an example. You should never, ever, ever have swap turned on for your application, or the container, or the operating system, or whatever your app is running on. Because what's worse, having the swap start kicking in and getting used, and then your app performance goes down like this, or your application crashing, right? Which is worse? Your application actually crashing is the better option there, because at least you know that there's something wrong. You can scratch your head for hours like, why is this system all of a sudden getting slow after running for an hour or two, right? So you never swap. All right, so let's get into tools for perf testing, and we'll run a demo in just a minute. So I typically tend to use very simple tools. Most of you have probably used Visual VM. We'll have a look at it in a minute. I like to use the garbage collection plugin in Visual VM to monitor a system when it's running to see what the GC looks like, or what the profile of the GC looks like. We don't have time to get into Java Flight Recorder. JFR is a really nice tool for when you have CPU constraints, especially. Of course, going into Java Flight Recorder is an hour session unto itself. But the problem with something like JFR is that it's an intrusive test, i.e. it adds load to the system because it's collecting all this profiling data. Right? So you have to be careful when you use JFR because you're actually affecting the performance of the system by using this specific tool. I'm not saying you should never use it, but just be aware that it does add load and overhead to your application. Right? Someone asked about generating load. There's some decent tools to do that, which are freely available, like JMeter and Gatling. Actually, I think Gatling has a booth here, don't they? So, yeah, right. Anyways, I generally tend to use JMeter, but there are other tools. You can use Selenium if you like. Doesn't really matter. And there's some nice tools from the command line, like JStack and JStat, to take thread dumps and heap dumps or get garbage collection information, etc. Okay? So what I do want to spend a little bit of time on, because most of you are probably familiar with these other tools I already talked about, is something called JHiccup. Now, this tool is something that was invented by the CTO of our company, Gil Tenney, who's also a Java champion. And what it does is it essentially just measures any kind of pause that happens in a running JVM, right? And the pauses can be either from the JVM itself or from the underlying operating system or somewhere in the system. Who knows, right? Could be network, whatever. But what it does is it measures those pauses. And the way that it looks, well, we'll get to what it looks like in just a second. But what we get is we get this output then of how long these pauses happened in the JVM, and then we can use a tool called a histogram log analyzer, which we'll look at in just a second. But the basic premise of JHiccup is that it sleeps for a small amount of time, 1 millisecond, there's an M missing there, and it wakes up and records the last time it was awake. That's basically the tool. It's that simple, okay? Now, if we look at this from a chart form, this is what it looks like. We record at what time we woke up and went to sleep, and that's basically it, right? So every millisecond, this is the time, this is the time, this is the time. And whenever there's a pause in the VM, for example, because of garbage collection, that pause time in that thread will be longer. It won't be 1 millisecond, it might be 20 milliseconds or 100 milliseconds, depending on how big the heap is and how long the garbage collection in this example takes. Okay, but again, it records anything that's happening in the VM or in the underlying operating system will get recorded. So, or you'll be able to see that there was some kind of latency there, right? And it will help you isolate where the performance issue will be. Right? We'll see in just a second. Anyways, here's another chart, similar. 1 millisecond sleep time. We record how long it was since the last time we woke up, and that helps us to know at what point in time on a wall clock there was some kind of pause in the VM. And then you can correlate that to something in the log file or a garbage collection or whatever. Okay? So in the way that you use JHiccup is it is a Java agent. So we're actually going to run this in a minute. You add a Java agent and you set it to the JHiccup jar file, and then it will go and put all the information into a log file. Okay, so this is one of the unobtrusive tools I was talking about. There's a single thread running that just says, okay, when was the last time I woke up? And just keeps doing that every millisecond, and it helps you correlate when there is some kind of pause in the system so that you can look at your application log or you can look at your database log, or you can look at your GC log to say, okay, this is why there was this pause, or this latency is because we did a garbage collection, or the database was very busy at this point in time, because you have the timestamp for when this happened. Okay? So another tool that we're going to use is the Zulu GC Log Analyzer. It's available for Zulu and OpenJDK. It hasn't been released yet publicly, but it should be soon. But you can use any GC tool you want. Some people use GC Easy, for example, which is a nice website where you can just throw in garbage collection logs, and it'll give you a nice graphical output. Okay, so let's talk about the demo real quick and run the demo. Okay, so what we're going to do is we're going to use JMeter to drive a Spring Boot application. I'm going to enable debug level garbage collection logging, and we'll have the JHiccup logs, and we'll also look at this application while it's running in Visual VM, right, just to see what's going on with it. So we're going to use JMeter to drive load into the Spring Boot app. We have this logging that's going to happen. We'll also hook in Visual VM just to see what this app looks like and what it's running like. Okay, so let's see. I have everything set up already. So here's JMeter. And the app that I'm going to use actually is the Spring Pet Clinic app, right? So I tried to make everything where, you know, when you're at home on Saturday, you can open up a bottle of wine and run these demos and, you know, experiment with this if you like. Okay? So you can pull down all this stuff from the internet. If you go to, it's all in the slide deck at the end. But it's basically, I'm just going to run the Spring Pet Clinic application because it's open source and everyone has access to it. And more importantly, they also provide a JMeter test plan. Okay, so if we look at this JMeter test plan, what this thing does is it just runs a couple of different things. Go and see how many users there are, how many pets there are, find an owner, go and edit the owner, et cetera, et cetera. It's basically just exercising the application, putting it under load. Okay, so let's go fire this up. All right, so now we're started up, 2.8 seconds. And now I'm going to click this button, and let me make sure this is set right. The number of threads, that's too many threads. Let's do 200 threads with a ramp-up time of 60 seconds, and we'll loop 100 times. All right, hopefully that'll work. Let's see what happens here. Okay, so, oh, it looks like we've already ran into some issues. What happened here? Okay, actually, you know what? Let's go look at it in Visual VM. I got it open here somewhere. Nope, that's that. Where's Visual VM? It's over here. Okay. Here's Visual VM, and here's Pet Clinic. And then let's go to the monitor, and let's see what's happening. Okay, there's our heap. Let's go to the Visual GC. Let's see. So you can see that we're exercising this application. And for those of you who have looked at garbage collection in the VM before, this is what we want to see, right? You can see that we're using memory, and then we collect it. We're using memory, the VM collects it, et cetera. We get that nice seesaw effect in the Eden space in this case. And we should be hitting some garbage collection pauses along the way somewhere. Let's see where that's happening. Okay, the CPU usage is pretty low, 10%. And you can see our heap is, I was hoping to break it, but let's see if I can break it. Let's see what happens. We'll just look at this first, and then we'll try to break it if we are not able to break it right now. So we'll just let this run for a minute, and we'll watch this mesmerizing graph as it goes. All right, that's probably long enough. So when I ran this, when I was testing it last night, it didn't take long to get some good results out of this. So, but this is the Visual GC plugin for Visual VM that I'm showing in this tab, and this is just the overall monitor for this application. Okay, let's have a look at the metaspace. Metaspace isn't going to change for this. All right, so should we keep this running? No, let's kill it, actually. Okay, so first of all, let's go look at, that's the GC log analyzer. So let's go look at the logs for this. Okay. So our log file should be in, that's strange. Okay, we're gonna have to run this again. I'm sorry. I did have that graphic with the train falling off a bridge, so. I forgot to include the GC log, or the GC login. Of course, it won't be here. Okay, here we go. Let's try this again. Oh, actually, before we do that, let's make sure we clear out our log files. Okay, let's go run it again. Visual VM should show that that is dead now. Okay, let's go fire this up again. And let's stop JMeter because that's not online yet. Okay, let's do this one more time. I'm sorry. Let's remove this log. Yes. Okay. Oh, let's remove this guy too. Okay. All right, let's make sure JMeter is not running right now. It's not. Now we can fire this up. Right, now I have the GC logging turned on. Okay. So let's turn this on. Our website is up. Our web app is up. Let's go get JMeter going again. Let's go to Visual VM. And let's make sure that this is running. All right, that. Okay, there we go. All right, so we'll let this run for about a minute. And we'll go have a look at the garbage collection and some other logging. Actually, I don't need to turn this off. This will just keep writing to the log file. Actually, while it's doing that, let's go look at the log file. Okay. I was playing around with CRAC, or Checkpoint Restore Coordination, for another demo the other day. Does anyone know what CRAC, or Java Crack, is? Yeah, if you haven't heard of it, I think my colleague Garrett Grunwald is doing a presentation on that today, or maybe he's doing something else. Basically, it's like instantaneous startup for Java applications, but it's not GraalVM. So if you haven't heard about it, it's pretty cool tech. It's something that Azul has been working on for a while. Okay, so let's go into Spring Pet Clinic, and let's go see what's in this log file. Okay, so this is just the, if you remember, I started up this specific application with, well, you can't see it now, but basically I started this app with garbage collection set to debug level. So it's basically printing out all this garbage collection information. And you know, eventually you can figure out how to read this, but I don't really dig into this unless I absolutely have to. I just use a GC log analyzer to help me understand what's going on with it. But you can see it's pumping that data out right now. So I'm going to go into GC log analyzer, and now I'm going to open that, and uh-oh, it's not good. This is going to be a very short demo if this doesn't work. Oh, that's a new one. I haven't seen this one before. Okay. You know what? Let me go stop the application. Maybe that'll help. Okay. Now let's try opening it. Okay. This is going to be fun. All right. We'll try this one more time, and then we'll just move on to, I actually took screenshots of everything, so all is not lost. All right, let's go into JMeter, turn this off, and we cleaned everything up. Let's go fire this back up. Let's actually go and increase the heat. Oh, that should be good. There should be enough heat for this. All right, one more time. We'll try this one more time, and then we'll move on to the screenshots I took of this app running earlier. Okay, so let's dial back the number of threads. Let's not hit it so hard. Okay, and open this up in Visual VM, make sure it's working. Okay, it seems to be doing something. Okay, we'll run this for about 60 seconds, and then we'll go have a look at the log output and see what we got. Okay, let's see if it'll open it now. I'll just try it now. Okay, success. I'm not sure why that didn't work last time. Okay, so let's go look at the GC pause time. So hopefully, I know that's a little small, but I can't make this font any bigger in this specific application. But what I'm doing here is basically I've loaded up the garbage collection debug logging in this garbage collection log analyzer tool, okay? And you can use whatever tool you want. This is one that we have internally, but we're going to release this at some point. But if I hover over here, you'll see that at 1.4 seconds, and that's by wall clock, at 1 seconds after the app started, there was a 50 millisecond garbage collection pause time. Okay? And then here at 2.4 seconds after the application was started, there was a 13 millisecond GC pause time. And then it looks like there's an outlier here too. Now, this is just looking at GC pauses, basically, right? There's a number of other things that we can look at here, but this is what we're interested in when we're doing a performance profile. We want to determine if the garbage collection is causing a lot of latency in the system, i.e. making the app run slow, or we're doing too many garbage collections, maybe we need to add more memory, maybe we're not doing something right in the app and holding on to things, which can eventually lead to an out-of-memory error, et cetera, right? But we're just looking at GC pauses for now. So let's go look at the JHiccup log. If you remember, JHiccup was that thread that wakes up every millisecond and lets you know if there's been longer than a millisecond pause in the system. Okay? So let's go open this up. Here's our hiccup log, and this will take a second to load. And here's that nice chart that we were referring to earlier. Okay? So if you remember from the beginning of this presentation, we were talking about P99 and P95 or 99th percentile latency and 95th percentile latency. So with this hiccup log, or with this graph here, I can determine for the system what that latency, the P99 and the P95 is. Okay? So if you look here at the bottom, let's see if I can zoom in. That looks okay. Right. So here's 99 percentile. And that looks like our P99 in this case is just below the first dotted line. So actually we have a really good P99 of let's say 4.5 milliseconds, okay? So in this case, I can say for this application, our P99 is 4.9 milliseconds. And if we go to our P90, actually, I forgot that you can actually hover over it here. It looks like our 40th percentile, let's keep moving up, right. So you can see as we approach 95, our P95 is basically 4 milliseconds or something like that. But what's interesting here is also the top part, because one of the reasons we take this JHiccup log is to see when there was something in the system that caused some kind of latency. And what we can do in this case is we can actually look at this and say, okay, it looks like there's a latency at about 5 seconds, approximately 5 seconds after the VM started, of about 51 millisecond latency at that point in time. So what was happening at about 5 seconds after we started the app that caused about a 50 millisecond delay? Right? If we flip back to here, okay, that was at 1.4 seconds. What did that say? It said this was at 5 seconds. All right, let's find this one. We'll find it here somewhere. Okay, so max per interval, I'm sorry, yeah, 5 seconds. Elapsed time of 20 seconds. There was a 20-second delay. So we come into here. Actually, let's go find this 36 here. Right, so at 35 seconds, there was a delay. So approximately right here, what I'm trying to do here, if you haven't figured it out, is I'm trying to correlate a garbage collection pause to the JHiccup pause that we saw in the system, right? So what we should see is for each one of these things, because we're not doing anything else here, we're not hitting a database, there's really no other external factor, I'm not really running much on this laptop, so each one of these spikes in latency here should correlate to probably a garbage collection, and that's what I'm trying to correlate here, is when we hit this thing at 2.4 seconds, I don't know why this log doesn't show at or doesn't show that initially, but at least at 20 seconds, we should see like right around here some kind of latency that correlates with that garbage collection. Okay, so this is how we basically do unobtrusive performance testing. We run this JHiccup log. It gives us these spikes. It also lets us know what our P99 and P95 is. But it's the spikes which are useful, because the spikes, again, for example, at this one, this was 60 seconds after the VM was started. There was a latency spike of 41 milliseconds. Now I know that, okay, at this point in time, something in the system caused some latency. What was that? Now I can go and correlate that. I was hoping to get a perfect correlation to this. Let's actually open this up again. Let's see if I can get a refresh. Nope, that's not going to work because this is still running in the background. But anyways, that's the premise behind this, is with these simple tools, garbage collection and JHiccup, we're able to try to isolate when something went wrong, and then we can correlate that to some factor, whether it's garbage collection, a slowdown in the database, and other things like that. Okay? So let me go stop this, because this is just null pointering for some reason. I think I hit it too hard. So anyways, we have a few more minutes left, so let's round out this discussion. So I did take screenshots of everything in case the demos didn't work, right? We looked at Visual VM. We looked at JHiccup and the latency distribution. We looked at the Visual GC plugin for Visual VM. We looked at the garbage collection log analyzer also. And then just a few other things real quick. We talked about load previously. Real load is better than simulated load, but hey, you do what you can. But I think the first bullet on this slide is really important from a Java performance engineering point of view. Depending on which JVM you're running, pretty much all of them, it can take a long time for the JIT to really optimize code. So when I'm working with somebody and we're trying to see what the performance profile is, we don't look in the first minute or 5 minutes or half an hour, because that's not long enough for the JIT to get warmed up. It literally takes 20, 30, 40 more minutes for the code to really optimize, so that's what like your real performance actually looks like after that point in time. So you have to wait for the JIT to warm up before you really consider the performance profile of an application. So we generally tell our customers at least an hour before you actually start taking some performance metrics. Okay? So we've talked about these things already. We looked at the how to collect garbage collection logs. It's a lot of fun playing around with JVM settings and flags and stuff like that. But aside from tweaking the amount of heap space, sometimes the Eden and stuff like that, you don't really have to mess with it too much, right? You know what your application is, and you'll say, okay, I need 256 megs of RAM, or half a gig, or a gigabyte, or more of RAM for this application. Then you generally don't have to mess with it that much, unless you see a lot of garbage collection that happens too frequently, or your garbage collection is too long, right? If your garbage collection is too long, what do? You try to reduce the amount of heap you have, right? If you have too many garbage collection pauses, then you increase the amount of heap you're using so that you don't get as frequent pauses, but you'll get longer pauses. All right, so we talked about this already. We can also change the GC algorithm. How many people use a non-standard garbage collection algorithm in Java? Just out of curiosity. Which one do you use? What's that? Is that GC? Okay, yeah, that's a good one. Anybody else? No? Wow, it's only one person. That's surprising. There's usually a few people out of like, a few hundred that use a different garbage collection algorithm. Okay, so we've talked about this already. I'm already 1 minute over time. We talked about JIT warm-up time and garbage collection warm-up time a little bit already. We've already discussed correlating JHiccup latency with garbage collection and what that can look like for thread contention. OS bottlenecks is a good one. How many people run Kafka here? Just out of curiosity. Well, it's quite a few. Okay, so for those of you who raised your hand, what's the one trick that you can do to increase your Kafka throughput? What's that? Yeah, you can partition it, but this is even simpler than that. This sounds like an article on the internet. One trick to make Kafka run faster, right? Anybody else want to take a guess? No, that does help, right? So when our customers switch from using OpenJDK to Azul Prime, which uses continuous garbage collection, a pauseless garbage collection, that does help. But this is even simpler than that. The answer is actually on the slide in one of these words. So to make Kafka run faster, just get better storage. Instead of using a spinning disk or a regular SSD, use a high-performance solid-state drive, and you'll see an incredible jump in Kafka throughput. So it's little things like that that can add up. All right. We didn't have a chance to look at stack dumps, thread dumps, but that's, again, profiling. And let's see if there's anything else. We talked about Visual VM, fixing and repeating the tests. Only do one fix at a time, of course. And that's basically it. And again, if you want to try these experiments at home, I've linked to all the tools that I've used here on this slide. So please take a picture. And I know I'm over time and it's lunchtime. And for some reason, if you run over into lunch, you get much worse reviews. So I'm going to stop now. And if you have questions, I'll be up here happy to take some questions. Thank you for coming.